Hello, Julian Mustangs. Right now I'm going to go over the math spiral review for April 30th and May 1st, and I will give you some answers and go over some techniques for those. So the first one we're going to look at is this word problem. It says Mike wants to buy the same number of balloons for 8 of his friends. He has $59 and each balloon costs $7. What is the largest number of balloons that Mike buys for each friend? Now, at first, this problem can seem a little overwhelming, but what we need to keep in mind is what is the largest amount of balloons that Mike can buy for each of his friends, not him included. And there are 8 friends, and he has $59 to spend, and each balloon costs $7. So if we look at it this way, we can kind of start with, all right, so Mike has 8 friends, and we need to know how much he can per balloon. And we can only have about $59 to spend. So if I just start with having Mike give each friend 1 balloon, or $7. So for 8 friends, 1 balloon is $7. That would mean that he's going to be at a total of $56. Now, what I see is he only has $59 to spend. Really, this means I only have $3 left over, and a balloon costs more than $3. So I'm kind of already done with this problem. If he has 8 friends and he buys 1 balloon per person, or he spends $7 on each friend, he would spend a total of $56 and nothing more. So this is pretty much his budget, 1 balloon for each friend. Okay, that's the solution. I think it's probably easier than you were expecting. All right, number 2, find the perimeter of the office. I'm going to stop and pause here and remind you that perimeter is not multiplication. Perimeter is going to be length plus width plus width. Label the length of the diagram to help you find the answer. The rectangular office is 3 times as long as it is wide. Well, here's the width is 4. So what we're ultimately going to be doing is 4 times 3. And I can prove it because each of these boxes would be 4 because he is multiplying it by 3. So if I do it this way, 4 times 3 is 12. So the length of this side is going to be 12 feet. So the perimeter is ultimately going to be 4 plus 4 plus 12 plus 12. Oops, sorry, that last 2 was weird. Plus 12. So if I break it down, I have 4 plus 4, which is 8, and 12 plus 12, which is 24. When I add those together, I can simply add on, or there are multiple ways to add this, but basically if I go 24 plus 4 is 28, plus another 4 is going to be 32. So his perimeter is a total of 32 feet. For the next one, enter the missing digit to complete the following statement. The only thing you have to do in this one is fill in this box. However, there's something I'm noticing right away, and that is the ones column is not lined up correctly. So if you just went through and put a number here without lining up the numbers, you were probably off a little bit. So I'm going to start this problem by lining everything up correctly. 1, and I'm going to put this box here to show it's missing. Minus 7,923 will give me a total of 4,120. So I'm going to go ahead and double check and make sure everything lines up. So I'm looking at my ones column. 3 minus 3 is 0. 4 minus 2 is 2. Let's see. When I get to this column, I am noticing that 0 minus 9 I can't do. So whatever number is in this blank column, I'm going to have to borrow from that. So I would have to borrow from whatever number this is and make this 0 a 10, making it so that 9 or 10 minus 9 is 1. Now the trick here is to figure out what is missing. So 7 plus 4. So basically what I'm doing is I'm going backwards. What number plus 7 and 4 is going to give me here? So this number minus 7 is going to give me 4. Keeping in mind that I borrowed. So if I go 7 plus 4 and work backwards to figure out what should be up here, I go 7, 8, 9, 10, 11. 11 should be here, or 1 should be here. But I also notice that I'm borrowing. So if I put a 2 in this box, it might work out for me. So if I go down here and try, and this could be a trial and error, you could have tried several different solutions, but if I tried 12,043 and then subtracted my 7,923, I would find that I have 0 and 2. I would borrow from the 2, make it a 1, make this 0 a 10. 10 minus 9 is 1. 1 minus 7, I cannot do that, but if I borrow from this 1, make it a 0, make this an 11, 11 minus 7 is 4. So I can see that I have the same answers here, meaning that the missing digit is then 2. Okay. Next one, rounding. You need to round 283,850 to the nearest thousand. Write your answer in the box. Keeping in mind that the thousands place is this 3 right here. So when I'm looking at this 3 is going to look to the 8 to tell it what to do. This 8, if it's 5 or more, it's going to up the 3 score. And if it's 4 or less, it's going to let that 3 rest. So since the 8 is in that category of 5 or more, it's going to bump up this 3 to a 4. So when I rewrite my whole answer, I'm keeping the 2 and the 8 there, bumping up the 3 to that 4,000, and then keeping everything behind it zeros. So I'm rounding that number. The next one that I have to round, it says you're going to round 283,850 to the nearest 10,000. So I'm looking at this 8 right here to round. So I'm looking at another 8, but this 8 this time is going to look to the 3 to tell it what to do. Since the 3 is 4 or less, it's going to let this 8 rest or stay the same. So I'm going to keep everything in front of that highlighted place value, such as the 2, let my 8 rest, and then keep everything after that zeros. And so 283,850 rounds to 280,000. My next problem. Susan says 4/8 and 1/4 are equivalent fractions, and this is what she did. Is she correct? So right away when I'm looking at this problem, I can see that 4 divided by 2 is not equal to 1. So right away I can tell that this is where she made her mistake. So is Susan correct? No, she's not correct, because 4 divided by 2 is not 1. Okay, and that's exactly how you can explain yourself, or you could say something like 1/4 is not equivalent to 4/8. Last problem for the day on this one. Amelia ran 3/5 of a mile on Monday and 3/5 of a mile on Tuesday. How many miles did Amelia run in those 2 days? So here's our key question. How many miles did Amelia run in those 2 days? That gives me, since I'm asking for this how many miles, and it looks like I have to combine the 2 days, this is an addition problem. So I'm going to take 3/5 plus 3/5. Now, when we're adding fractions, we make sure to keep those denominators the same. And since I'm keeping my denominator the same, I know it's going to be a 5. But then with numerators and fractions, I add them together. So 3 plus 3 is 6. Now, you could say that Amelia ran 6/5 of a mile, or some of you may have noticed that the numerator is bigger than the denominator, making this a fraction greater than 1. In order to change this greater than 1 fraction into a mixed number, I can put a number bond in it, take out a whole number, and find out what's left over. So because my denominator is still 5, I'm going to make sure that my denominator stays 5 in this number bond. Okay, and then what I'm looking at is I need to pull out a whole number from 6/5. Don't forget, a whole number in fractions means the same number over the same number. So if my denominator is 5, then my numerator also has to be 5 to pull out this whole number. And then I have to think, okay, 5/5 plus what is going to give me this total of 6/5? Well, 5/5 plus 1/5 gives me a total of 6/5. Therefore, my mixed number for this, and I'll just draw a big 1 hole over it, this 5/5 is actually a 1 whole, and then my remaining fraction is 1/5. So, how many miles did Amelia run in those 2 days? You could say that she ran 6/5 or 1 1/5. Sorry about my dog, you guys. I'm sure you can hear him in the background. He's just excited about something, I'm sure. So now we're on the May 1st worksheet. And the first problem says Jillian bought 6 toys that each cost $8. She also bought 2 toys that each cost $9. How much did she spend on the 8 toys? This is a lot of directions, but it's pretty easy. Basically, we're answering that how much money did she spend altogether kind of thing. So we're going to be doing multiplying and addition. So when I look at this problem, I first see that she has 6 toys that are each $8. And then she also bought 2 toys that cost $9. So my first set, I'm going to do 6 times $8 to find out how much she spent on those toys. And then I'm going to go ahead and add up how much she spent on the 2 toys, which were $9 a piece. So I'm putting them into the parentheses to show they're separate things. So I'm going to start with the 6 times $8, which means 6 times 8 is, that's right, 48. So she spent $48 on those 6 toys. And then we have to find out how much she spent on those last remaining toys. So 2 times 9, which is $18, and then you add those 2 numbers up. I like to always make sure that my numbers are stacked, so I'm going to go ahead and stack them down here to double check my work. 8 plus 8 is 16. I put down the 6 and regroup the 1. 4 plus 1 is 5 plus 1 is 6. So the total she spent was $66. Okay, next one. Miss Stone bought a poster board that is 2 feet wide. It is 4 times as long as it is wide. Draw and label a diagram to represent the poster. Use the diagram to help you find the area of the poster board. I don't think this box was in your worksheet, but you can go ahead and draw one in for yourself. I must have put it in there while I was doing my Zoom meeting with everyone today. So the first bit of information we need is that the board is 2 feet wide. So I'm going to go ahead, I'm going to put that in a different color first, 2 feet wide. So I'm going to go ahead, I'm going to put 2 feet on the side to show that it is 2 feet wide. And then the other piece of information that I need to know is it is 4 times as long as it is wide. So to help myself visualize this, I'm just going to go ahead and cut this into 4 pieces, because whatever this amount is up here is going to be 4 times this amount. So that means that this would be 2, and this would be 2, and this would be 2, and this would be 2. So ultimately I'm doing 2 times 4, which is, you guessed it, 8 feet. So last but not least, my last direction on this was to find the area of the poster board. And in order to find the area, I need to multiply width times length. So I'm going to multiply my 2 times 8, and I get a total of 16 square feet for this poster board. Okay. Next problem, select all the expressions that have a product of 450. Product is the answer to a multiplication problem. So basically you got to take and multiply all these numbers to figure out which one of these equal 450. I'm going to go ahead and zoom out and move it over a little bit. So my first one, I'm going to multiply 12 times 45. I'm going to do so, I'm going to use black. I'm going to do so with my box method, and I'll do one for each. So when I multiply them together, I'm pulling apart the 12 with the 10 and the 2, and the 45 with the 40 and the 5, just like we've been doing in class. So my first box, 10 times 40, is going to be 400. And then I'm multiplying 40 times 2, which is going to be 80. 10 times 5, which is 50. And 2 times 5, which is 10. And my last step is to add all these up, but I can already see right away this is going to have more than 450. So 400 plus 50 plus 80 plus 10. Woo boy. So 0, 8 plus 1 is 9, plus 5 is 4. Regroup this 1. 4 plus 1 is 5. So nope, A is not going to cut it. My next one is 18 times 30. So I'm going to go ahead and draw. Let's see, let's get rid of this part. You can pause it if you need to. So now I'm going to do the same thing for 18 times 30, but I don't need to make 4 boxes on this one. I just need to make it into 2 because 30 has a 0 in that ones place value. I'm going to separate out the 18 into 10 and 8. So 30 times 10 is 300. And 30 times 8, or 3 times 8, is 24 with 1 0 at the end. So to figure out if this equals 450, I'm going to add up that 300 plus 240. And I see that I get 540, which if we flip those numbers around, it'd be correct. However, not an option because it does not equal 450. So do the same thing with the next problem. I'm going to try 40 times 17. So I'm going to take this, 40 on the side, make 2 boxes for the 10 and the 7 on the 17. 40 times 10 is 400. And 4 times 7 is 28 with the extra 0 at the end. I'm going to add these two numbers up, 400 plus 280. And I get 680, which is still not our 450. Oh boy, they're making us work for this one. Okay, the next two problems, while not complicated, they just added an extra step. So what you have to do with these next two problems is you have to take up and you have to multiply this number and then multiply this number and then multiply those numbers together. So what I mean by that is 9 times 5, I'm going to zoom in a little bit. 9 times 5 is 45. So we're going to take and multiply 45 by 6 times 2, which is 12. So when we do our math squares, that's the two numbers that we're going to be breaking apart. So I'm going to make my boxes, and I'm going to put 40, let's see, let me do pink this time. I'm going to do 40 and 5 to break apart 40 and 5, and I'm going to do 10 and 2 to break apart that 12, and 40 times 10 is still 400. 10 times 5 is 50, 40 times 2 is 80, and 5 times 2 is 10. Oh boy, so if I add up 400 plus 80 plus 50 plus 10, I don't believe I'm going to get, let's see, 8, 9 plus 5 is 4, carry the 1, 4 plus 1 is 5, still not an option. So, holy cow, so far none of these are viable. I hope the next one, because I really want to see one of them make it. Next one is going to be the same thing. We're going to go ahead and we're going to multiply 9 times 2 first, and then we're going to multiply 5 times 5, and then we'll multiply those two numbers together. So 9 times 2 is 18, and we're going to then go ahead and do 5 times 5, which is 25. So we're going to multiply those two numbers together using our boxes, of course. So I'm going to pull apart the 18 into 10 and 8, and the 25 into 20 and 5. So 10 times 20 is 200. 20 times 8 is, or 8 times 2 is 16 with a 0 at the end. 10 times 5 is 50, and 8 times 5 is 40. So I'm going to go ahead and add up all these numbers. Oops, I put 54. 50 and 40. Okay, my ones column is 0. In my tens column, I have 6 plus 5, which is 11, plus 4 is 15. Put down my 5, regroup my 1. 2 plus 1 is 3, plus 1 is 4. Woohoo! We finally have a winner, and it is E. So that problem was simple enough to do. It just took a lot of work, and you can pause it anytime if you need a chance to work through it. Oh boy, this one's also very similar. Select all the expressions that have a value of 24. This is a fancy way of finding all the division problems. So the expressions would be division problems that equal the value of 24. There's a couple that I can see right away that I could do in my head. One of them is 150 divided by 5. Another one of them is going to be 400 divided by 8. And the other one is going to be this 300 divided by 3. So I'm going to start with the ones that I can easily do in my head. 15 divided by 5 is 3, with a 0 at the end makes this 30. So B is not an option as it is not a value of 24. I'm going to do D next. 40 divided by 8 is going to be 5, with the 0 at the end for the 0 right here. 50 is also not a value of 24, so that is also not going to be an option. On my last one, 30 divided by 3 is 10, with an extra 0 at the end is going to be 100. Not a viable option, so now I only have 2 left. I'm going to do regular long division for this. So 6 does not fit into 1, but it does fit into 14. 6 fits into 14 2 times. Multiply it down. 6 times 2 is 12. Subtract, I have 2 left. bring down my 4. 6 fits into 24, or 6 times what gives me 24? That is 4. And 6 times 4 is 24. Subtract, and I have no remainders, but my quotient is 24. So A is a winner. I'm going to check one more to see that it's correct. I'm going to go ahead and erase this problem all the way. Okay, so for my next one, I'm going to do 5 into 120. So 5 does not fit into 1, but 5 fits into 12. 2 times, and multiply. 5 times 2 is 10. Subtract, and I have 2 left, but I need to also keep bringing down the 0. 5 fits into 24 times. 5 times 4 is 20. Subtract, and I have 0 left with a a quotient of 24. So C is also a correct answer. So A and C for this one are correct. So this next problem has us draw 2 fractions that are equivalent to 1/2. I already have these boxes put in apparently from our Zoom meeting. You can go ahead and draw those in as well, as it'll help you do this lesson. So since we don't have to show it using our numbers, we only have to use it by drawing it. I'm going to go ahead and start with drawing out 1/2 and shading them in. So I'm going to shade this one in pink, and I'll shade this one in blue. Now my job is to draw 2 fractions that are equivalent. Here, so on the top one and the pink one that I'm working with, right now I have 1/2, but if I were to cut both of these boxes into 2 pieces, I now have 2 pieces shaded out of 1, 2, 3, 4. So my equivalent fraction, so I started with 1/2, broke it up, and now my equivalent fraction is 2 pieces shaded out of 4 total. So an equivalent fraction of 1/2 would be 2/4. Another way I could do this is break each box up into thirds. So I could have this being broken up into thirds and this one being broken up into thirds. And so when I started with 1/2, I broke it up, and so now I have 1, 2, 3 pieces shaded out of 1, 2, 3, 4, 5, 6. So another equivalent fraction would be 3/6. And that's exactly how you would do that problem, shade it in. That's how I suggest you go about getting that one done. And last but not least, select all the fractions that are equivalent to 8/10. I'm going to remind you really quickly of place value, and that is we have our hundreds, tens, and ones, our decimal, and then it goes into tenths with the THS at the end, hundredths with a THS at the end, and of course that last one, I bet you could figure out the pattern, would be thousands. So when I'm looking at the fraction of 8/10, or not the fraction, I'm sorry, the decimal of 8/10, I'm just going to look for the fraction that literally states what I'm saying. And if I look here, I see 80 hundredths, I see 100 eighths, 80 hundredths, 100 eighths, 10 eighths, which is not say the same thing as 8/10. And D says 8/10. That's exactly how I'd say this, because this 8 is in the tenths place value. So this one, D, is going to be an option. Oops, sorry, not C. D is definitely going to be the same thing as 8/10. Now I'm going to go ahead and rule some things out. 100 eighths is not going to be 8/10. Just saying it out loud and hearing it, I know that's not true. But also, if I were to take 100 and divide it by 8, I would get some whole numbers out of that. C is also not going to be correct because our denominator is 8, and 8/10 means our denominator is going to have a 10 or a multiple of 10 in that value, so that's also not going to work. When I look at E, I see 80/10, which 80 divided by 10 is going to be a total number of 8, so E is also not 8/10. However, A is kind of that special circumstance. So in decimals, if we take off the zeros, which is perfectly fine, I'm left with 8/10 here, and I can pretend like these 2 zeros don't exist. And so this is also equivalent to 8/10, okay, or 8/10. If I were to keep it 80 hundredths, I would write 80 hundredths in decimal form as 80 with the 0 landing in the hundredth spot. because in decimals, this last zero can be here or not be here, 80 hundredths is the same thing as 8 tenths. You guys see the 8 tenths there? So our two viable options for this of what is equivalent to 8 tenths would be, of course, A and D. Those are the two that would be equivalent to 8 tenths. All right, you guys, this was a long one. I hope it helped you out, and be ready for phase 3 math work. Hopefully I'll see you in a Zoom meeting.